Welcome back to our second lecture on waves and optics, and this one deals with mirrors and lenses. Now these are we call it thin lens equations because if they're thick then we have to do some other things to it, but these are thin lens equations. You notice the first one is 1 over f. Now this f means focal length, so be careful on that. And the d sub naught, d sub I, d sub 0, or whatever, O is your object and your image. And these are consistent all the way through. M is magnification. There's no units, so this is, you're probably looking at this. Do I need all that? No. Just get what you need. Here's one, when you're dealing with lenses, this F is still focal length, and it's half the center of curvature, which is just a fancy name for the radius. So, let's get started. Okay, it says, okay, an object is placed, a convex mirror. So, whether it's a mirror or a lens, don't panic, you're still going to use the same equations. I wanted the location of the image. So it's so here's my D sub O, and here's my F. Don't panic with this, okay, because it all works out. We'll worry about that later. So this is 1 over F, 1 over D O. Now some books may use an S here, but the procedure, well, I tried to talk to S and I started writing an S. There we go. Okay. Okay. We have a focal length, so that's 1 over negative 0.5. Okay, and the object, that's 1 over 2. And where's the image? Okay. And then it's just a little quick calculation over this. And since we're dealing in meters, or units, and you notice I did not give you units on this like meters. You don't need to convert, just look what units are given in, because some mirrors are in inches, some mirrors are in centimeters, some are meters, some are feet. Just kind of watch it. Okay, and the magnification, okay, it doesn't have anything about the height on this. So we can just say the magnification is di over d O. Now I want the m. Now I know that my object is 2. Now what you're going to do, you're going to get this and just put it right there, and magnification is, okay, there's no units. It's going to be and if you think of it, you might see an X if you've looked at microscopes, a number with an X. This just means times. So if you see a lens with 100X, that just means that it is magnification of 100 times. Same thing here. Here's another quick one. This is the Hale telescope, which used to be the biggest one back when I was y'all's age, but it's not. We've got bigger ones. Okay, 1 over F. Yep, that's the reason why you use a pencil. There we go, and it has, okay, it has a focal length, and that's 16.9. Okay. He stands in front of this mirror, and actually, they do stand in front of the mirror. That's that big. Okay, 20 meters, and it says where the image is located. And then we do that. On the other hand, and if we wanted the magnification, okay, nothing about the height. If it was given height, then you could work out, and since we're just given distances, and then you could just, so the magnification, once you had this, okay, I am 20 in front of this, 20 times. So what I would do is take whatever answer I got this and just put it over there, and there it is. Only use this one, let me give you a little hint. Only use this one if your teacher is real mean to you and gives you the radius of curvature. Okay? Of course, then that's because normally they would give the focal length, but if you don't see focal length, but you see radius of curvature, you just have to take half of that to get your focal length and then just plug it into your thin lens equation right here. And so, yeah, like right here, like what I did to these poor students right here. See radius of curvature? Okay, got 1 over f. I know I got to find the image. So there's, that's, yeah, I keep wanting to put d, di. Okay, now I've got the object. It's 30 centimeters. Now you do not need to convert to meters. Just keep it in those units. I want to know where the image is. Okay, let's go and do that. And equals centimeters. Okay. Okay, so I got to find the focal length. So focal length is equal to 1/2 of the center of curvature, or the radius of curvature. That's another way you can say it. It's just normal, like I said. Center of curvature is nothing more than the radius. 1 over 2 times 40. We know that's 20. Normally I'm not going to calculate that, but okay, so we're going to take that 20, put it over here, then solve as before. You can actually use where your image is, you know where your object is. You can find your focal length of your mirror, and in some questions you will, and in some labs you actually do this. And you're just using these equations right here. How easy can this get? Okay, good luck. Enjoy the rest of the problems.